Alright, let's start with the second problem of the day, which is going to be add two numbers. This is LeetCode number 2. You're given two non-empty linked lists representing two non-negative integers. The integers are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero, except for the number 0 itself. Okay. So no leading zeros. So each node in the linked list represents a new or a digit in a number. And we want to return the linked list as a, or the number, the sum as a linked list as well. So I think the straightforward approach would be to, let's see, build up, at a high level, build up both of the numbers and return the new linked list as a, and return the new linked list. So this would involve using, so that would say start with 2 pointers at each of the numbers. For each node you traverse until the end, multiply existing number and add digit. Multiply existing number by 10 because we're working in base 10. So basically this 2 right here, once we move to this 4, we should multiply this 2 by 10 to get 20 and add 4 to it, so 24. Once we shift again, we shift this again, multiply by 10, so we get 240, and we add 3 to it. And then we continue to do that. The problem really becomes if we need to say if we need to borrow, or not borrow, overflow the sum. Sorry, carry over. That's the word I was looking for. Oh my gosh, I'm actually like my brain just like chugs on elementary level terms. Yes, if we need to carry over the number, the sum, to the next digit. Because this would imply that we would have to add a carry amount, and at the end, potentially add a new node. I guess the question then is, would we only need to add one node at most with a sum? And I think the answer to that actually is yes. So, what I'm thinking, and actually the reason why I'm doing this is, the straightforward approach takes O of n time and O of n space, where n is the number of nodes in the longest, in the longer list. Because we need O of n time to traverse the longer of the two lists, build up the solution, and then we need again O of n time to actually build the resulting list, and we need O of n space to actually store it. However, we might be able to get away with doing it a little bit more, having a slightly different approach. We could probably reduce to O of n time and O of 1 space by reusing one of the lists. And that would be in particular probably the longer of the lists. Let's see. Assuming this is the class definition, we are able to reuse the nodes because these are variables and not values. If they were values, that means that they would be read-only, and then the only solution then would be to produce a new list, a new linked list. So we have the option to override the values, and I think that presents an interesting approach then. So let's say that we wanted to do this. I think what we do, so the different approach is to start by reversing both of the lists. The reason why we need to reverse both of the linked lists is that we want to start from the ones column and build up our carry from the left, or from the right to the left, because that's how we do addition in at least the American world, right? We go from right to left, we start with the ones column, we add them up. If there's a carry, then we move it to the tens column, then the hundreds column, and so on and so forth. So in order to do that, then we need to reverse both of the lists so that we start with the ones column rather than the highest column, right? So we start by reversing both of the lists. So this would take O of n time. Then we would say keep track of a carry bit. And also, this would also allow us to know which list is longer and use that list as our output. We keep track of a carry amount and start traversing the array backwards. Or sorry, not the array, the lists backwards. Adding or setting the longer list, setting the longer list's value to the sum of both as well as the carry amount. So it would be, for example, here it would be 3 plus 4 plus carry, which starts off as 0, right? If carry is greater than 9, then value is equal to carry mod 10. And we could actually just do carry mod 10 regardless. And then we can do if carry is greater, then the value is carry mod 10, and then carry divided by 10. Because of course we only want to move over one, the most significant digit, right? And since we're dealing with only the single, at most the nodes have a value between 0 and 9, that means then that the carry at most will have 2 digits, right, to work with. And we only really care about the first digit, or the leading digit in that case. Then we can say continue until we reach the end. And if the carry amount is not 0, well, continuing, yeah. Let's see. Else carry is equal to 0, right? We want to reset carry each time if we use the carry. If the carry amount is not 0 at the end, add a new node with the amount left in carry and return that as the new head. Well, add a new node with that in carry as a tail, then reverse the list one more time. So this would take O of n time. This whole traversal, entire traversal, takes O of n time as well. So this is actually less efficient in time versus space compared to the straightforward approach, because of the fact that we need to reverse the list twice. And so this would take 3n time, essentially, whereas this would only take 2n time because we traverse this at the same time. We build up the number at the same time. Yeah, we build up the number at the same time. We add them and then we build up the final list. So that would take only 2n time. So O of 3n versus O of 2n. But at the same time, that doesn't necessarily matter because of the fact that we do save space. Constant values don't matter, or constant multiples don't matter, and we save space. So let's see. Which one do I actually want to do? Let's go with the more difficult solution. Oh, I completely read the question wrong. So they're stored in reverse order already. So we don't need to actually reverse the lists initially. We can just reverse the final list at the end. Okay. Let's revise our approach then. Still, 2 pointers to add the numbers. The new problem then is that we don't know which list is longer without traversing through them once, because it's a linked list. So we kind of need to do, so step 0 is to figure out which of the lists are longer if either of them are, which will take O of n time. This will also take O of n time to just do 2 pointers to add the numbers, reset, and do the carry stuff. And then does it want us to return the list in... Does it want us to return the list in reversed order? Okay, no. So this will actually take just O of 2n time O of 1 space. Because we return the list in reverse order as well. Okay, that's not bad. In that case, we can do... okay, we can get started with coding then. We can say var carry is equal to 0. And this will be an integer. We can say var runner 1 is equal to L1. Var runner 2 is equal to L2. While runner 1 is not null and runner 2 is not null. We can say late init val or var longer list head, and this will be the head of the longer list, whichever it is. If both of them are the same length, then it'll default to one list one probably. Runner 1 is equal to runner 1 dot next. Runner 2 is equal to runner 2 dot next. Also nullable. If runner 1 is equal to null and runner 2 is not null, then runner 2 is, or then the longest list head is runner 2. Otherwise, longest list head is equal to runner 1. So if runner 1 is null and runner 2 is not null, then we set it to runner 2. Otherwise, we just default to runner 1. If the longest list head at this point is still null, then we just return null. And this is just a just in case part. Although this shouldn't happen because within the problem description, it says that the number of nodes in each linked list is at least 1. But that's fine. Then we can say, well, late init var other list head. And the reason why we need this is just so we so we know which head is which. So now we can say while longest list head is not null, we can say that longest list head dot val is equal to the sum head dot val plus carry, or plus other list head dot val. In case this is 0, then we will set it as 0. Same thing here. Though we know that actually within this context, we know that this longest list head will not be null within this while loop. Let's set a val sum to this amount plus our previous carry. So this sum will be our current amount plus our other head amount plus our carry, our old carry, if that has any amount. If the sum is greater than 9, then we can say longest list head dot val is equal to sum mod 10. And then we can say sum or carry is equal to sum divided by 10. Otherwise, our longest list head dot val is equal to sum, and our carry will reset to 0. And then we can return, or at the end, so now longest list head, longest list head is equal to longest list head dot next. Other list head is equal to other list head question mark dot next. We want to go until the next value, until the tail of this is potentially null. And in that case, we'll probably need to do this because we don't know whether or not the longest list head will be null. Well, technically it shouldn't be null because at that point, the longest list head, if it's null, then it'll return. So this should not be null. We'll see if Kotlin agrees with that. So now we're at the last element in the longest list head. And we will see that if carry is greater than 0, then longest list head, which is now at the tail, dot next is now equal to a new list node, which has a value of carry and a next of null. And we can say here val original list head is longest list head and original list head. So we did pretty much what we intended to do. So first we go through, do an O of n traversal to see which item is, or which list is longer. And this is important for the purposes of actually getting back our sum, or seeing which list to add our sum to. Then we will say, let's see. Actually, this is not important. Val original list head is equal to L1. That's null, then L2. And we'll say if L1 is null and L2 is null, then we just return null. Though again, edge case won't happen in LeetCode because of constraints, but that's not a big issue here. The original list head is either L1 or L2, and then the val, let's see, because we kind of do need that. And then val, well, do we need? We'll say that we'll stick to L1 as our original list head. Let's see if that was null. Otherwise L2, yeah, and then val other list head. This is a var. Our list head is original list head is equal to L2, otherwise L1. If L2 is null, we don't need this. And then we can say while list head next is not null. And this idea is that we want to just move list, or move the sum to list 2, no matter, or to list 1, no matter what. And we can do that by doing this list head. List head shouldn't be null. Other list head could be null. Then we do this. Let's see. If other list head dot next is not null and list head dot next is null, then we say list head dot next is equal to a new list node, with 0 and null as our carry, or 0 and null as our next value. And then we set our list head to our list head.next, and our other list head to there. And then at the end, if we still have a carry, then we'll set our list head next to list node to the carry amount, a new list node, and then we'll return the original list head. So the idea is that we don't need to worry about which one is longer, because we can just append the list or new nodes to our list if need be. It's just that list 1 will be maybe shorter. In that case, we'll add more. If list 1 is longer, then we don't need to do that. And then here we add the sum, which is our current list value, plus our other list value, plus our earlier carry. If it's greater than 9, then we we set our value to the sum mod 10, and we move our carry to the most significant digit, which will be only 2 digits in this case. Otherwise, we just set the value to the sum, and then we set the carry to 0. And if there is no next for our current list head, but there is a next for the other list, then we should add another node. And then we set it, and then we also set u. And if there's a carry at the end, then we create another list node. And at the end, we just return that list. So that seems to be fine. Let's go ahead and throw in a run code, and let's see if there's any compilation errors. Okay, so it seems like it's not happy about list head. So list head could be potentially null, I guess. So let's just do that. Is it also bad at the bottom? Yeah, it is. Okay. So the original list head is one of them, and then the other list head is the other one, whichever one is not null. Well, we can say if original list head is equal to L1, then L2 else L1. So it's the other value no matter which one. Though I think actually our previous little shortcut should have worked. So I'm going to keep it like that for now. And let's go ahead and run a run code, and let's see where we end up. Six 0 3 1. Let's see. So 703. So this is different. Interesting. So we added 3 and 4. 4 and 6, and then 1 should be here. And in that case, our sum should have been 8. And in that case, then our val should have been equal to sum, and then our carry should have been 0. While our next is not null. Well, it goes here. It adds it. And then we go to the next. And then we check that it is null. Okay. Then do we want to do... Then we can do this. So while... In that case, then we do this. And then we can say if other list head dot next is null and list head dot next is null, and our carry is not, or our carry is greater than 0, then list head next is equal to list node carry null. So what this will do is that if our next value is null, so now we've set it so that we move our list head all the way until null. So now we will actually include this last calculation of 3 and 4. And after we calculate this 3, 4, and 1, we will say that if the next value, like let's say that the carry here was like 3 or something, like, or yeah, 3. So 3, 4, and 3 is exactly 10. That's greater than 9. So we set our list head val to 0. And then we set our carry to 1. And now our next for both of these lists are null. And our carry is greater than 0. So we set our list next to have a carry, we create a new node at the end, which will be a value of our carry. And then we need to set our carry to 0. And then afterwards, when we run through this cycle again, because list head is now not null anymore, when we do that, the sum will be carry plus 0 plus 0. And in that case, it'll just be the sum, it'll be the carry 0, and then it just runs through one additional iteration at the end, which is perfectly fine. It's just one iteration, it won't scale with the input size. So let's go ahead and run through all the code examples now that the first example works. Okay, looks like it works. And let's go ahead and run a submit. And there you go. So pretty average runtime, pretty average memory usage. So main thing was just reading instructions be hard when you're blitzing through it. But yeah, the idea that it's stored in a reverse order is really, really helpful, because then we can just do math in sort of our traditional style, and we don't need to worry about reversing the list initially. Though I would imagine that it would be kind of cool if this originally wasn't a in the reverse order. Then you would have to do the intermediate step of actually incorporating the reversal linked list. I think that would be I really like those LeetCode problems that incorporate other LeetCode problems from previous difficulties. I think that they just like really, really help to build the skill and reinforce like using it in different ways. But in any case, we just do the calculations in our way digit by digit. We keep a carry. And then at the end, if there is a carry, once we run out of nodes, we just add a new node, and then we return the head because we don't need to reverse the list. In any case, I hope you learned something, and I'll see you for the next problem.